Hello everyone, welcome to my channel. If you're new here, my name is Ronak and I'm a statistician and also a consultant eager about data and data analysis. In my channel, we interpret data using different statistical techniques through SPSS software and Python programming language, and of course, in the foreseeable future, the R programming language. So let's get started. In this video, I'm going to teach you how to run logistic regression in Python. In general, there are three types of logistic regression algorithms. The first one, which is binary logistic regression, and its response variable is binary in nature. The second one is ordinal logistic regression, that the response variable has three or more possible outcomes in a specific order. And lastly, multinomial logistic regression, which its response variable has three or more possible outcomes, just like ordinal logistic regression, but with this difference that they have no specified order. So here in this example, we will run binary logistic regression. We will build a model that predicts whether a breast cancer tumor is malignant or benign, which is a binary response variable. So we will be using the breast cancer Wisconsin dataset, which is available from scikit-learn datasets. And you see, we name our dataset cancer1. Then for seeing the name of the columns or the independent variables, we use the feature underscore names. And then for target variable, we use target underscore names to see the name of the target variable. You see, we have 30 predictors. For convenience, we convert this dataset to pandas.dataframe. So we import pandas as PD. And to prevent from upcoming errors, we replace every space in the name of our variables with an underscore. Because sometimes when there is a space in the name of the variables, Python just throws an error. So lastly, we use the shape property to see the number of rows and columns. You see, each tumor or each row contains those 30 predictors we saw as columns. In the next step, we add the response variable column to our dataset because at the moment there is not such column in our dataset. And then we see the shape of our dataset again, and you see we have 30 columns now. Which new column contains the output or response information of our dataset. Now we split up our predictor and response data into training datasets and testing dataset. But why we would do that? We will use the training dataset to train our logistic regression models, and then we use the testing dataset to test the accuracy of our model predictions. That's the reason behind it. So we do that using train underscore test underscore split function from scikit-learn model selections. But I should add that in this model, we only use the first 10 columns of our data frame, and we select these 10 columns using ilog, and then put them in the variable called x, and then put target variable in y. So we finally split the data. Now, in the next step, we're good to go to build the logistic regression model. There are several ways to build a model, and you can go ahead and use any of them that you feel most comfortable with, but in this tutorial, we'll use the logit function to fit our model. So this function requires two arguments. The first one is a string formula detailing which columns are predictors and which column is response variable. The second one, which specifies the dataset. So we fit the model, and then we can look at the model summary using the summary method. In the result table, you see we have the coefficients for each variable. Now we can test our model on the testing data using the predict method. And finally, we can determine the accuracy of the model by looking at the accuracy score and confusion matrix which we call it from secular metric package. We run the cell, and you see the accuracy of our model is 95%, which is pretty good because it's very close to 100%. And if you're interested, you can also visualize the confusion matrix using confusion matrix display, plot function, and show function. So we do that, and here is the result. The upper left quadrant displays the number of true negatives, meaning that 49 number of tumors diagnosed as benign, and the model accurately classified as so. And the lower right quadrant displays the number of true positives, meaning that 88 number of tumors diagnosed as malignant, and the model hopefully accurately classified as so. But the two other quadrants, the upper right one and the lower left one, show our model's misclassifications, meaning that the upper right one, which is 5, shows the number of tumors that were benign, but the model misclassified them as malignant. And the last one, the lower left one, which is number 1, shows the number of tumors that were malignant, but the model misclassified them as benign. And that was it. Thank you so much for watching this video. And if you found it helpful, please subscribe to my channel for upcoming videos. And I'll see you in the next video.